Hello and welcome to this demonstration of the ErlangCalc software part 2. My name is Peter Loader, I'm the owner of PL Insights and also the author of the ErlangCalc software. If you're not familiar with the Erlang concepts and you haven't watched it already, you might want to watch my introduction to ErlangCalc. Similarly, if you've not seen part 1 of this demonstration, that will help you understand some of the concepts and how to navigate around the software. Otherwise, let's get straight on to part 2 of the demonstration. Firstly, we're going to have a quick look at the input and output screens for the weekly model using a model that I built earlier in true Blue Peter fashion. Then we're going to run a couple of scenarios to give you a bit of a flavour as to what it's like using the software in practice. So, starting again with the home page, let's move swiftly onto the navigator. And now what we'll do is we'll go through screen by screen the inputs and then move on to the outputs. So configuration, similarly to the single Erlang calculator, we can give each scenario a number and a description. And then also on this screen, we've got our performance metrics. So target answer time of 10 seconds. We're aiming to achieve 90% within that. People on average will wait 5 minutes before abandoning. We've got a 2% abandonment rate target, a couple of other additional parameters that I won't go into, and we've also said that we don't want our agents to be more than 85% utilised. If you need more information about any of these parameters, I do urge you to look at part 1 if you've not done so, where I do cover what these parameters are and how they're used in more detail. A bit more sophisticated on our demand page. We've got the ability to enter weekly demand for a year. You'll see that goes up to the 52 weeks, quite a lot of variability in this particular demand data set. And we've then got an hourly profile of our demand specified here. Now this can be used as actual numbers, or alternatively, we can weight our weekly demand according to the proportion of demand that occurs in each hour. And that's done by selecting the method over here. So if I wanted to run week 1's demand, which is 2,356, which we can see here, then that 2356 will be apportioned proportionately according to those demand factors entered in column I. And that's the resultant demand that we would get in each hour, in that case of the Monday. Alternatively, we might want to take the average or mean weekly demand, which is only 1,911 per week, or in this case we're going to pick the 90th percentile, so a pretty busy week. That's effectively going to be the sort of around about a third most busy week of the year, with a demand of 2,220 or so, again apportioned through the week as indicated there. Similarly, process times can also be varied by hour of the week. In this particular example, we've just said that the handle time and wrap time are 4 and 2 minutes respectively, giving a total call duration of 6 minutes, and that's applied for every hour of the week. But if your call centre has more complex calls tending to arrive at particular times of day, that can be reflected by varying your average handler time. Also on this screen, we've got the requirement for the team to undertake non-core work. So I've called this tasks that the team has to undertake as opposed to their core demand over here. What you can see here, taking Monday as an example, is between 8 o'clock and 6 o'clock there are 2 hours worth of work to be undertaken. So that's going to occupy 2 people at 100% utilisation. And there's just a few formula here. It's adding up the total amount of work that there is to do. So at 10 o'clock there's 1.1 hours of core work plus the 2 hours of teamwork, giving a total of 3.1 hours worth of work. And the Erlang calculator will use that information to come up with its proposed resourcing requirement. Resourcing is the third component. If we're wanting to use the weekly planner to test a proposed resource plan, we enter that resource plan in this column here. So we're starting this simulation, this Erlang model, with a very simple resource plan of having 5 resources available in each hour of the week. Those resources are subject to a 12% of in-shift losses, so that's our sort of admin, breaks, briefings, those types of things that might occur. And Erlang Calculator has worked out the net resource that's available once those losses are subtracted, and then by dividing the workload that we saw on the previous screen into that net resource, we can work out the utilization of the resources through the hours. So you can see it's ranging from only 8% at 5 o'clock in the morning through to around 90% at 5 o'clock in the evening. And that's because we've got a varying demand profile but a consistent resource plan. And that difference is summarized on the input charts screen. So what we can see here is for each hour of the week, the dark orange shading is the core work that we've got. And if you remember, we had 2 hours of non-core work between 8 and 1800. That is added to that work in the lighter orange shading. And then the green line is the net resource that we had available, which, as we can see, is that constant 4.3 or 4.4 hours worth of resource. So there's always a little bit of spare capacity, but at the busiest times you can see it's very close to being 100% utilised. So that finishes off the input side of things. I'm just going to pause here and I'll be back with you in a mo to go through the outputs. So let's begin by looking at the summary outputs. Table in the top left has 2 columns. The first column of outputs is the planned results. So that's the outputs from our resource plan that we entered, which was the 5 resources per hour in every hour of the week. And the required column is what would the results be if we use the resourcing proposed by the Erlang Calculator. So we can see, for example, that the service level, we would get 72.3% if we deployed 5 resources in each hour, whereas if we use the Erlang suggested resource levels, we'd have a service level of 94.4%. Similarly, the abandonment rate of 16.8 versus 0.7%, an average wait time of 1.8 minutes versus 0.14 minutes. Despite this relatively poor performance, the resource utilisation is only 43.6%. And not only that, we've got 6% of all hours where our 85% maximum utilisation threshold is exceeded under that flat resource and plan. Part of the reason for that, you'll see that the resource hours deployed in the resource plan is only 840, whereas we're using 927 in the Erlang plan. So clearly a shortfall of resource is going to be part of the problem under that resource plan. The final thing to draw your attention to here too is the match score. 79.1%, whereas 100% would be a perfect match. So that's the ideal profile as suggested by Erlang. I've seen worse than 79.1%, but there's certainly scope to look at some shift patterns that give us a better match to the shape of the demand profile. The other thing we can do over here is to copy the key outputs and also a summary of the inputs into our scenario planner. So let's copy the key outputs, click on the scenario manager button and paste those numbers into the scenario manager using the paste special values button, as we did in the single hour example that I looked at in part 1 of this demonstration. So that will enable us to compare those key results with any future scenarios that we run. Before we look at further scenarios, let's just have a look at some of the other outputs that ErlangCalc provides. The first one is a summary of the difference between resources that was in our plan, which is the green line on this chart of 5 per hour through the week, versus what the Erlang Calculator tells us that we need. So we can see that actually there are times when we've got more resources than we need, and we drop down to 4 and even 3 at some hours during the week. But there are many hours where we should really be rostering 6, 7 or even 8 people, or having 6, 7 or 8 actually available to take calls and do that other work. We can then look at how the gap between planned and required resource correlates with the service level that we achieve. I call that the service level versus resource delta chart. So the blue line using the left hand axis is the service level. So we can see that in the early hours of the morning we're achieving 100% when we've got too many resources, but it drops down even below 50% during the afternoon. And the right hand axis is the difference between planned and required resources. So where that's positive, we've got too many resources. Where it's negative, there's a gap, and you can see the correlation between where we're short of resource and those deficits in service level compared to what we want to achieve. We get a similar picture on the abandonment rate. The abandonment rate's actually going through the roof. It's going through 50% in those hours when we get the poor service level. Again, that corresponds where we've got our resource gaps there. So 3 charts we can look at there. There's then a big table which contains all of the results that feed into those charts. It also gives you a bit of an insight as to how those resources are built up. I'm not going to go into the detail of that in this presentation, but you'll see that clearly that's going to enable a lot more analysis and alternative presentation of the results to be undertaken should you wish. I'm going to pause it there before we get into the first of our scenarios. In the baseline scenario, we saw that we appear to have an overall resource shortfall compared to what the Erlang Calculator had suggested we needed. So in this scenario, we are going to increase our 5 resources per hour to 6 per hour through the week. So let's go into configuration, define this as a new scenario. Call it number 102. Let's put a note in here so that we can remember what the scenario was about. And then let's go into the resource plan. We'll change the 5 to 6. I don't want to type in 6 168 times, so I'm going to use the copy paste special values so that I can paste those numbers in without losing any of the formatting that's been put into the software. You'll see that the net resource has now increased to 5.3, sounds about right, because 12% of 6 is 0.72, so to one decimal place that would come down to 5.3. And you'll see that our utilisation now, it was peaking at 90%, but it's now at 75%, so hopefully that will make things a bit easier for our agents. Let's go and have a look then at the outputs. That's all we need to do to configure that scenario. We can now see that the service level has increased to 89.8% from the 72% that we had before, and we're only 5% behind what we had in the Erlang optimal scenario. However, that's because our resource hours are now considerably more than the Erlang scenario. And despite the fact we're using another 81 hours per week, we're still not achieving that same level of performance. Our resource utilisation's dropped below that of the Erlang scenario as a result. Match score is still the same because we've still got the same shape to the resource profile that we're using. So let's store this scenario away in the scenario manager. Again, I'll paste special values into there. And it will enable us to compare that scenario with any future scenarios that we might create. Again, I'm going to pause that recording there. And now we'll run our final scenario, which is to test out some shifts that give us a resource profile that is no longer flat, but which attempts to meet the shape of the demand profile. So to do that, again, let's create a new scenario, number 103. And we'll call this the shift pattern test. And in Blue Peter fashion, I've already put a list of shifts into the shift to grid converter. So this shows us a table with a list of shift patterns here. You can see I've created a 12-hour early shift starting at 8 o'clock and going through to 2000 hours with 4 people on it, and also a night shift from 2000 to 0800 with 4 people on it. So that's going to give me 4 people at all times over the 24 hours of each day. I've then got some additional shifts that are shorter in duration, a day shift and a twilight shift, plus another 12-hour late shift. And these are looking to schedule people in during the morning and afternoon and early evening when we most need them to cover the peaks in demand. And the effect of those shifts is plotted on the resource grid chart below. And just by visual inspection, you can see it looks a bit closer to the demand profile that we'd created. The resource to grid converter is the mechanism that creates a resource grid that looks like the grid that we've got in our resource plan. And that's done by using some formulae to look at the start and end times and the numbers of people and create that resource grid. So I'm going to copy the resource grid that's been created from those shift patterns, which uses 924 hours in total. I'm going to go to the resource plan and I'm going to paste it into the planned resource field, again using paste special values. I don't want to change it into a mauve set of numbers. So there we go. And now we can see those numbers are changing hour by hour. Our peak utilisation at 5 to 6 o'clock has dropped further than it was before because we were actually rostering 7 at that busiest time. Maximum utilisation of 64%. We've still got a pretty low level of utilisation in the early hours of the morning, so there may be some further scope to improve this. If I did look at the input chart, you would see again we've got some correlation now between the shape of the workload profile and the profile of resource that we've got available. So let's see if it's actually made a difference. I go to the summary outputs. You can see indeed it has. We've now got up to 91.7% of our calls being answered within the target response time. So we're above the 90% threshold. Our abandonment rate is below 2%. Our average wait times come down to just under 0.3 of a minute. And our resource utilisation is very comparable. In fact, we're almost using an identical number of hours to what Erlang has suggested that we need. And our matched score to the demand has gone up from that 79% to 87% almost. Still not 100%, but the reality is we can't change the number of people in each hour of the day to match as closely, perfectly, the demand profile that we've got. Again, I can copy this into the scenario manager just to enable us for completeness to be able to compare those numbers side by side. There we go. So we've got the now those resource hours next to each other, so we can see how much it's cost us compared to the baseline, but how that's a much better solution than simply increasing the resource numbers. If we were to look at the planned versus required resource, it does seem that there's probably a little bit of scope for further improvement. If we started that early, that sort of day shift a little bit earlier, and reduced the number of people we've got at sort of 2-3 o'clock in the morning, then we could probably increase that a little bit more. Although we'd have to see what's happening over at the weekend. You can see on a Friday night, it's actually a pretty good match to demand there. So possibly some fine tuning of what we do on each day of the week would help there. If we look at the service level versus resource delta, you can see now the orange bars are smaller because we're much closer to the matched demand. We've still got some problems at certain times. Service levels dropping to the odd hour or two in the day below sort of 80%, but most of the time it's above 80% and really somewhere between 80 and 90%, and we're doing a lot better at the weekends now. So that concludes what I wanted to show you here. Just got a couple of summary slides to finish off the demonstration. Thank you for watching so far. So hopefully we've seen the software is pretty easy to navigate around, either by clicking on the worksheet tabs or through the navigator menu system. We've seen that we can obtain graphical and tabular outputs. The tabular outputs enabling us to take any of the information that either we entered into ErlangCalc or that the ErlangCalc software has produced and put it into other Microsoft products like Excel, and we can link that either from ErlangCalc to your worksheet or from your worksheet to ErlangCalc. We use the software to determine the optimal resource requirements for an hourly demand profile that varied hour by hour, and we also used the software to test proposed resource plans and indeed shift patterns, and saw that by matching the resources more closely to when demand occurs, we could get a better service level and abandonment rate at lower cost. So why would we use ErlangCalc? Well, clearly the Erlang approach is well established in the contact center industry, powering many of the workforce management systems that are used. There are also several free Erlang calculators available in spreadsheet form for more strategic offline planning, the sort of planning that workforce management systems are less adept at doing. So why would we use ErlangCalc instead of those free systems? Well, the first key feature, I think, is that it's accessible and it looks professional. By accessibility, I mean we can easily link our spreadsheets to ErlangCalc, either to import data into ErlangCalc or to extract data from ErlangCalc that we may want to put into other PowerPoints, Excel spreadsheets, etc. The second key feature is ease of installation. There's no need to get permission from IT departments because it's just a simple workbook. So that means your initial install or any upgrades that you receive are going to be easy to undertake, and also if you want to share it with colleagues, you can just send it via email and they can immediately view the resulting spreadsheet. The only limitation as a result of taking the non-macro approach is a limit on the maximum number of agents that the software can handle in any individual hour within a week. That's currently set to 100. It'll probably be quite easily raised to 150, but we'll struggle to go much beyond that sort of size. So if you've got a huge contact center with hundreds and hundreds of agents available in any hour, this may not be the software for you. Most importantly though, from my point of view, is that the software is designed to work in non-contact center environments and in conjunction with other demand management software. So for example, ErlangCalc includes several types of shrinkage, which I previously found to be critical to ensuring consistency of approach with regard to abstraction modelling in other process improvement and change assignments that I've been involved in. The software is designed to work with other tools that you're going to see if you continue to watch these videos as I develop further videos in the series. So finally, how would you gain access to ErlangCalc if that's something you'd like to be able to do? It's pretty straightforward. You just go to the website, use the link shown on the screen. There's the option to acquire it via PayPal. Alternatively, you can send a purchase order using the contact details provided, or even just simply send an email with details of where invoices should be sent to. There's the option to specify the contact address for where you want the software to be shipped to. It is purely something that we send out via email. It's not a huge attachment. It's a bulk standard Excel spreadsheet, so there shouldn't be any problems with it. There are two types of license. There's a personal license, which is for the named user only. Alternatively, there's a site license, which is for anyone located at the site that you specify. I'm not here to stop you from using it in the way that you want to. If you're not sure which of those two options is best for you, or if you want to do something slightly different, then again, drop an email to the email address shown on the website and or phone up, and that can be discussed, and I'm sure that a sensible arrangement would be reached. So thank you for watching. As I've said, this is one of a series of videos that I'm developing. If you are interested in seeing the others, then either subscribe to the YouTube channel or keep an eye on the website. Alternatively, you can follow me on LinkedIn, and I hope to see you again. Many thanks for watching. If you've made it to the end, well done.